So Evergreen is 100% dead. Put a bullet in it. It's cooked. It's gone. But the people who had the devices, as we have discussed previously, are not out. They are not somehow bereft of the equipment that they have purchased, because we have one of the members of the Evergreen team who swooped in, has saved the day, has released Garden OS. I guess it's just Garden now, no longer have the Druid at the beginning. But this is the OS that saves all of those devices out there. I thought it'd be great to come back and sort of, give a big high five to James for putting this out there, for delivering this to the community, and maybe to tell us a little bit more about how the release has gone, what is left in the future, where is this still going, and just kind of catching up on what's going on over at in the world of Druid Garden. So James, welcome back to FOMO.
Thank you for having me. Good to be here.
So you released, and there's more activity in the Discord. People are trying it out. How'd the release go? Did you find many bugs? You fixed a few things, it looks like. Is there a 1.1.0 or 1.0.1 on the horizon?
1.0.2, I think, is going to end up being released this year. We cooked 101, and then there were a couple of other bugs that people had posted that we decided we wanted to wrap up before we did a release. So we should have something out this week, wrapping up the few bugs we did find. But for the most part, everything was kind of a known issue ahead of time. Basically, something we had assumed would be a problem with the beta release.
And like, so they were known issues, but they weren't really that major. People found them, but otherwise mostly went off without a hitch.
Yeah, there were a couple weird little quirks, and there's a couple of things we didn't quite finish in time. Just we didn't expect Evergreen to shut down as quickly as they did. We expected a little bit more of a runway to kind of get some of the more features done. But there's a certain couple things, like when you set up mounting of your drives right now, if your device reboots, you have to go remount your drives. It's just little convenient stuff like that for the most part. There's not major bugs or anything that like prevents farming or prevents the OS from working. It's mostly just convenience and little features.
And how's the response been from the people that are using it and the community at large?
Everything I've heard so far has been incredibly positive, which has been very great to see. We've had a lot of people who have actually installed it. I know of at least 10 to 15 devices who have reached out personally and, asked questions and had us help them get them set up. We've had a lot of people ask about shipping out the SD cards, so we're taking a more serious consideration to that and probably going to figure out what we could do cost-wise for that and get those shipped out. I actually had somebody hit me up this morning about that already.
This is for the people who are loath to flash an SD card and kind of get everything all prepped for themselves. They just want to buy the card and jam it into the device.
We also have a number of users. When Evergreen was kind of towards the end of its shipping of devices, we had moved over to eMMC modules as opposed to the SD cards. And a lot of people are way less likely to want to work with those types of chips as opposed to an SD card. They're a little bit scarier to take on and off the board. They mount to a different weird adapter that nobody's going to ever have. So we're looking to also ship the SD cards for those users who don't necessarily want to deal with the eMMC.
Do you have to unsolder it from the board, or does it just snap off?
It snaps off, but it's one of those things where if you're not a techie person, you kind of feel like you're yanking too hard and you're going to break it. And so for a lot of people, when we've had them take off the eMMC for support sessions, they get really uncomfortable because it does feel like you're kind of snapping it off the board.
Definitely things like that in hardware where you feel like it's more pressure than is needed, but you have to apply that amount of pressure. I've definitely felt that
Yeah,
myself.
exactly.
So, given the fact that you have been so close to all the plotting, how the internal guts of Evergreen and Chia works, I'm curious about the revelations that have come forth with respect to the new plot format. And obviously there's a sunset of the existing plots. It's proposed to be pretty far out, but it is out there. How much have you been looking into the new plot format, and like what do you think of what you've heard from Dr. Nick and the rest of the crew? I asked Dr. Nick, and he said that they've actually been in direct contact with you. So I was curious to follow up with you about that.
Yeah, actually, Dr. Nick and I have talked quite a bit. I've talked with the Chia team as well about working on potentially integrating the new plot format into Fast Farmer. Definitely something I plan to do. Obviously, we want to get some of the bugs and other features wrapped up before we dive too much into it, but I would expect that once the plot format is ready to be used, Fast Farmer will support it.
Have you looked into the details of the plot format and how they think they've solved the whole GPU compression issues, or is that something that you really haven't spent much time digging into the guts of?
I've had a high level conversation with a couple of people about it behind the scenes. I haven't finished reading through all the technical stuff myself. Um, there's been a lot of other priorities I've had, so it's on my list. It's something I got to get to, but considering the plot format is a little bit of ways, I haven't prioritized it too much yet.
So largely a lot of positives around Druid Garden and Garden OS and the release. So you had a point release. There's another one on the horizon. I think it's interesting to hear that there's demand for pre-flashed cards, given that that's a not too hard operation, but I guess that is part of what was sold in Evergreen was plug and play. So having something that you can just put into the device and have it start working seems like it fits with the mold of what people were thinking about when they bought these devices, that they really wanted something that didn't require much intervention. That requiring no intervention isn't going to work when those those plot formats actually sunset. Any thoughts about how that could be dealt with? I know that there's this, ability to replot drives, but that seems out of the reach of some Evergreen users. Is it just that this was a way to keep things going for some period of time, or how much have you been thinking about what happens when they actually kill off those plots?
We're trying to cook up a solution to automatically slowly start transitioning people to the new format once it's available. So what I would love to do is to start slowly replotting people's systems over time as they continue to farm the old plots. We're generating new ones on the system and slowly just removing the old plots to replace it with that.
What would that be done with the Pi itself?
I need to benchmark it. I don't think the Pi itself will be able to do that. I think we're going to need some sort of a remote plotting service. And given with the new K sizes, you can have much smaller plots. I think the concept of doing plotting remotely over the internet is a lot more feasible now. So it's something we're cooking and looking into. Definitely a goal of ours is to be able to just let the devices keep running and not have the users even really have to know they're being converted to the new format. That would be the goal.
So one of the things that was tricky about doing remote plotting was that you had to hold on to these big files and it was hard to get them onto the device. So it's really the fact that the plot sizes are a lot smaller under the new style of plots that's going to make this more tenable to do it. Is that one of the key features that allows something like this to actually work correctly?
That's exactly it. Limiting, for example, a user to two plots, you no longer have to have 200 plus gigabytes potentially available for an OG or, you know, even still 50 plus gigabytes for a lot of the different compressed ones. So once we can have these significantly smaller plots for download, you can have them store 3 to 5 plots for just a few gigs up on some remote storage and then force them to have to cycle them to keep it going.
No, I think this is kind of a neat concept. So this would be, you've got all these Evergreen devices. Somehow they register for, hey, I want to keep my device alive. Here's an estimated time to how long it's going to take me to get all these plots. It's going to trickle feed them down via some resumable mechanism, rsync or something along those lines, and it's trickle feeding the plots into you. And anytime somebody downloads one, then what, you guys have a bank of GPUs sitting there, and it just regens a plot, drops it there, and waits for them to trickle download the next plot. Genius, absolutely genius.
Yep, that is the goal. We actually just picked up our first set of 5090s for our testing here, so we should be working with those pretty soon.
Now, who did you have to kill to find a 5090?
The Micro Center in LA, it just had a ton in stock. Like,
Interesting.
was not even an issue finding one. Walked in, I had my choice of the selection.
Huh. So the GPU shortages seem to be at an end.
It does seem to be that way. I mean, I think if you still look on eBay, there are people trying to scalp them. But yeah, there was no issue picking one up from Micro Center.
Is that because everybody's jumping on the Mac platform to run their large language models?
I think for most home users, yeah, the Mac Studio has become by far the most efficient way to run an AI model.
Do you want to talk about that at all? I know that you're pretty savvy about this kind of stuff. I'm curious. We can stay away from it if you don't want to talk about it, but hearing that there's 5090s in stock is a bit surprising to me. It's been a while since I went looking for one, and from what I hear from the industry, they were still gobbling up all the GPUs they could find. But maybe this is the turning point, because if you want to run the really sophisticated models, you need a lot more memory.
Well, I think Micro Center is doing a great job of limiting the amount of GPUs an individual person can come in and buy. So when we went in there, it was a limit one. Like I couldn't walk out with 10 GPUs if I wanted to. So I think that is helping a lot. But I also don't know if the 50 series has the same bite that the 40 series did when it came to even doing the compute or doing the AI. The
Oh,
50 series is
like a 4090 is superior to a 5090?
not in raw performance, but in cost per performance, yes.
Gotcha. So if you're trying to monetize the card and you're trying to get the most bang for the buck, setting up some large GPU cluster, the 4090 was the sweet spot, or maybe even is still the sweet spot.
I would say was. So this is definitely where the M4 or sorry, the M3 chip that now has the 512 gigs of unified memory on it comes in, because pretty much every single self-hosted large language model can be run off that up to like the largest sizes available. And the token performance on it is very comparable for what you are getting for the price. So it's not quite the same as running, 85090s, but you will get adequate performance and you'll still get a quick enough token response rate that it is a completely usable system.
So the GPUs that you've got, you're going to be setting them up in a cluster. Is this also enabling the remote decompression and enabling all the devices? I imagine with the larger compression that was shipped for a variety of the different devices that Evergreen sold, that remote decompression is a pretty key feature. And you guys are providing that compute resource to the farmers and the devices that are online?
We do not actually. So we've helped people get online with local GPUs, and then there is the compute service, recompute.io. We've been pointing people to them. I've been using their service personally and testing it for a bit, and it's worked phenomenal. And cost-wise, it seems to work perfect for where Chia is at. So we've been pointing people here. They have a great solution in place. I'm not trying to recreate it out of my house right now, but we are testing the 5090 for plotting, and then the newest builds that Max gave me for the farmer in the last week or so are all designed to support the 5090. So we had not actually gotten to test that yet, and having some 5090s on hand will let us actually test and make sure that all of that is working how we expect it to work.
But something like this and what Max has going, that all goes away when the new plot format comes out, right? Am I reading the room correctly?
For the most part, I think there is potentially still room for these services, given you still need some level of decompression for plots. And if people really don't want to use a GPU, this is still a great service for that.
So the new plot format actually has some ability to have compression and the utilization of a GPU. I must have missed that when I was talking to various people about the plot format, because I thought that that was completely out with the new plot format.
Maybe I missed something in talking with Dr. Nick. I know GPUs are critical still for plotting. It was my understanding if you wanted to still have a very large farm that you would still want to have a GPU.
Interesting. Lucas, do you remember hearing anything about that?
Yeah, I remember. Nick did mention that. I think because the queuing or the scanning of the number of plots with these smaller case sizes was part of the reason that he thought a GPU might still be for the large farms would be needed. James, the question is, you're talking about Apple and plotting. Is it going to be feasible to use phones for the replotting of these smaller sizes, or is that Twitter dreaming?
For the plotting of them, no. For the farming, very likely. We've actually heard already that some people have gotten farming to work on Android devices. So if you can hook up a drive and you can have an Android device running the compute, it can farm.
But it needs a remote full node.
It does need a remote full node service, yeah.
So are they doing this on a phone using Fast Farmer?
It was my understanding that yes, it was a fast farmer.
That's pretty cool. The first farming on a phone was done with your tech. That's pretty awesome.
It was exciting to hear. I want to try and get my hands on it so I can actually play with it, but I have not yet. So
Thinking about this GPU utilization with the new plot format, I can't imagine that that's a remote thing though, Lucas. If this is something where it has to do with scanning and the number of plots and stuff locally, I just can't imagine that that's something that can be done as a remote operation. Maybe I'm thinking about it wrong.
I didn't think that was an instance of using remote GPU. I thought that was on hand.
Yeah, so the context with which I was asking the question was recompute.io and what Max was doing. You know, there were these things where essentially there was some entity that was away from where your drives and your farm was, and they augmented what you were doing. So in the world of compression and these more exotic plot formats, there was this sense that you were paying a developer fee and you were using remote decompression, and there was like this external thing to you that was was required and that made your farm more efficient, made it so that you could earn more money from utilizing your space in a way that other people didn't, that weren't using these services. And I was just speculating that in the world of the new plot format, that likely none of those things could continue to exist because the plot format doesn't lend itself to doing anything like that. Now, that's not saying that some smart guy doesn't figure out a way to crack these plots and do something that was never intended. I mean, that's essentially what happened with the OG plots. And I was trying to ask Nick more about that when he came on the show, and really we went into the deep dive of how the format works and whether there was anything like that that could exist. And I suppose it's kind of a weird question to ask somebody. It's like, well, how do I hack and break the thing that you just tried to fix? Well, he's like, oh, I don't know. If I would have thought of it, I would have already fixed it. But I just don't see how anything like that can exist if they actually pull it off the way that they said they were going to pull it off.
So I did find a note on chia.net when they were talking about the next generation of proof of space. They're saying that basically if you're less than a petabyte, you would just need a strong CPU. If you are higher than a petabyte farmer, you would benefit from an integrated GPU or some dedicated GPU.
But that's got to be local to your system.
That I don't know.
It's got to be. Well, anyway, I guess we'll have to ask. So if there's some smart folks out there that are listening to what we're talking about, leave a comment and let us know if you got the answer for it. Otherwise, the next time we get somebody like Dr. Nick or Bram or somebody else to come on the show and tell us what's going on, they will we'll have to ask them that question. Are you participating at all in the chip process? I know that part of this is we're being asked to weigh in on whether we think this plan is a good one, the timelines are appropriate. There's 2 chips out there that are being asked to comment on from the community. I know that Dr. Nick indicated that your voice was one that they really wanted to hear from. So, did you comment? Are you planning to?
I have not commented yet on the chip, um, and I'm not 100% sure if and when I will. I know I've talked a lot privately with them about my opinions and timelines and stuff like that. But my past experience dealing with the chip process and some of the team around it has not been the best. So I don't know exactly what I will end up doing there.
That seems like the common sentiment from anybody that I ask about participating in the chip process is that they're loath to do it, and it's fool me once kind of a situation. Nobody wants to
It,
repeat those engagements.
it's exactly the same reason I won't make a pull request for them anymore. The last time I did a pull request, they passed it along to a different engineer, had them rewrite the whole thing so that none of my initial stuff was in there, and then pushed it without co-authoring me on the commit. Even though I pushed a bug that would have prevented any farmer with a K size larger than 33 and a compression size larger than 18 from farming. So I fixed a bug that was preventing a set of plots from farming, and I didn't even get credit for it.
Yeah, it's an unfortunate thing that we have this kind of bit of a situation that exists within the repository. I guess that's one of the reasons why I've always been very excited about what you were doing with developing your own full node. Is that still progressing? Is that one of the things that's been keeping you so busy that you're not going to participate in the chip process?
It's becoming more and more of a priority for me. I have some other contracts and stuff I am working on right now that would also benefit from having an independent full node. So it's looking more and more like it will be a priority and something we end up working on. It is still something, sorry, we end up prioritizing working on because we have been working on it. But yes, no, that's still cooking and in the works.
Can you give us a little bit more on that, because I know it's something that has been on the minds of a lot of people as far as the independence of the chain, its ability to have, a diverse ecosystem. What is the current focus of the efforts, and how far along are you?
We have a lot of the basic, we'll say, passive parts of the full node done. So connecting out to the network, hooking up to the other nodes, watching the block creation process and seeing how things are moving along, basically tracking all of that, storing things in our own database. We have a decent chunk of the block generation code and the validation around that done. And then we are hoping to finalize most of the WebSocket protocol, the active part of it, not the passive part of it, pretty soon here. And then the RPC and all of that is basically done. Most of those just hook into database or make simple calls. So that part's not that
So,
bad.
so you're one of the few people in the world that has thoroughly gone through pretty much everything related to Chia, from wallet to plotting to farming, now to block gossiping, block creation, block validation. Now that you've had a chance to see all the rest of that, any insights or things that you're kind of surprised at, or is it all pretty much what you expected to see?
It's a lot of what I expect. There's a lot of the error validation that feels very, in the current code base, feels very slapped on, kind of like we did error validation A and we realized we needed to do B, and so it just kind of got slapped on the bottom, even though it probably could have been integrated and tied into most of A, so you didn't have to redo loops and stuff. So there's a lot of stuff like that that we're just rewriting and skipping over. But for the most part, the code base wasn't that surprising. It's a Python code base.
So how much has the tests in the code base allowed you to know that you got it right, or is it a lot of hand validation?
I use a decent amount of their tests. I'm not a big fan of the way Python's testing frameworks are set up and kind of the way even these ones are set up in the Chia repository, if you actually look at the test struct and like the format itself and trying to figure out what it's doing, it's actually not always very clear just from reading the test code. So we are writing a lot more of our tests from scratch. And to top it off, we're not necessarily able to test things the exact same way that Chia does because we fundamentally do a lot of the code differently.
Can you tell me any more about that? Because I'm kind of curious about, as you're going through and getting a chance to rewrite what you see, that's oftentimes an opportunity to do things substantively better. So I guess I'm kind of curious about this one, is that the tests themselves are so tied to the code base in Chia that they can't be reused when the code gets refactored and done a different way. Tell me more.
So it's more of the fundamental way how Chia's code base handles the CLVM objects and how the Druid Garden code base handles the CLVM objects. So in the Chia one, they use an allocator, something where they can store memory into, and they pass it around with all of the objects. And so when you're actually looking at an object, most of the time in the code, you're actually dealing with a pointer into the allocator. And then if you want to read the actual value out of the pointer, you have to ask the allocator for that value, which is why you have to pass the allocator around with you throughout the whole code base as you're working on stuff. I wasn't a big fan of that, but there are benefits to it as well. But our code doesn't do that. There's no allocator. You don't have to pass anything around like that. And a lot of the memory is just kind of handled by the standard library, which also has, again, advantages and disadvantages. The one big advantage that Chia has by running an allocator everywhere is it does make the conversion to Python and to WebAssembly much easier because you have your own custom allocation. You don't have to worry about the standard library. You can basically drop it, and then going to those other FFI bounds into, like, again, Python, JavaScript, WASM, all of that becomes much easier.
So really, some of the reasons the code exists the way it does, or even that it was coded the way it was, is because they've always been interoping to a more performant library, whether it was C++ or now it's Rust. I guess there was some C code in there as well, right?
Yes. Yeah, and that interop has kind of always pushed their direction of building it with this allocator. It's my understanding that Chia actually had a lot of internal discussion around whether they were going to be using allocators or not.
And since your code base is entirely written in Rust, you don't have these issues. You've been able to do it the Rust native way, the Rustism way.
When I switch to WASM and put out WASM builds for people, there will likely be some small updates I have to make to get the allocations to work correctly. But for the most part, yes, I don't really have to deal with any FFI issues or weird isms I have to do to get it to work with Python.
And as far as one of the primary benefits that will come from having a purely Rust full node, is it performance and memory? Is that some of the things that are going to come first and foremost? Like, I mean, a full node is a full node is a full node. It does the thing it needs to do, but you're going to be able to do it with less of a memory footprint and do it in a substantially more constrained environment.
The memory footprint's going to be a big one. Just having a runtime in Python usually consumes more memory than, a Rust runtime. This is really clear with the farmers. I mean, Fast Farmer especially. If you don't have any plots, so you're just running Fast Farmer on its own, it's usually only about 15 megs of RAM. And it's a, zero CPU. It's not doing anything. But even with the Python code bases, you put those in there, you're usually in the hundreds of megabytes of RAM, and you also usually have CPU, even if you're just sitting there doing nothing, because the web server that's running in Python generally just is not efficient, and it is still running, it's not compiled, so you're still having issues where it's still real-time processing, and it's just not going to ever be able to compete with something like Rust or C or any of those kind of compiled languages. So you're always going to get the benefit of lower memory, lower CPU usage. And in general, because of both of those, you're also going to end up with less power usage, which for the low power devices like Evergreens is a big deal.
And so when you have a full node in Rust, is it going to make its debut in Garden OS? Is that the first place we'd expect to see it, that you just integrate it there and then now these devices live completely autonomously from any kind of a remote full node?
It will get integrated into Garden OS, but I don't know if that will be the first place we see it. I think a standalone full node is going to be the first product that comes out, and then how to run it as a plugin in Garden OS is going to be something we're going to help people do.
And do you envision that it's something that would be able to run without an SSD? That was always one of the big constraints, and it was something that Chia said, well, the only way you can have enough performance on the disk to run the database and to be able to get access to blocks and what have you is to do it in a particular way. Do you have some tricks up your sleeve that are going to allow you to run on these spinning hard disks, or are people going to have to plug in some USB SSD into their Evergreen device?
I think if we're sticking with SQL-Lite databases, Chia is not wrong. But there are a lot of other database formats out there, and there are also ones that are designed around running on, spinning disks or, flash disks like SD cards that don't have a lot of power. So if you have a database that is kind of built around that, I imagine you could still do it. Obviously, this is something we
Wait,
still have to test.
one question on this though. Since you have such a lower memory footprint, can you do something intelligent with keeping a lot more of the database in memory so that you can do this stuff in memory and then just flush out? Is that one of the techniques you're thinking about, or is that not really going to work?
We kind of do a lot of caching in a lot of the systems anyways right now, but yes, I mean, if there is caches you can put into memory as opposed to storing on disk, there's a lot of stuff that we can try. Especially given the farmer is going to use very little RAM. And if you use a GPU, and this actually applies to the new plot format too, you don't have to use a GPU, but if you use a GPU, the RAM usage is basically nothing because you can store everything just in the GPU's RAM. So having that, I mean, most Raspberry Pis are 4 to 8 gigabytes, and you can store quite a lot of data in cache there.
So I haven't had a chance to really dig into the guts of what the full node needs to do when it's validating blocks. I imagine a lot of what it needs to do is say, are the coins that are being spent validly being spent? And to do that, you might have to look at some amount of previous blocks. Is it where if you have some kind of a cache hit, there's a block that you need to look at, or some state of some coin that you need to retrieve from persistent storage that you would then have a cache miss and you'd have to go fetch it from disk? I don't really understand like why there was such a need for the SSD to begin with. Do you have a sense of why it was required and what it is that's sort of making that work correctly? Is it because everything is flushed out to disk and Chia is constantly reading stuff from the database and really isn't doing much in the way of caching?
But that's exactly it. As far as my understanding, looking at the code base, is every time they need data from the database, they go ask for it, and it gets stored during the use of that function. I haven't seen a ton of caching code in any of their code base, and as far as I understand, that is exactly why it is a problem to run it on a low-powered storage device. Is there is a constant need to talk to the database to validate coins, blocks, etc. And something that we've been doing kind of some look at the chain and look at transactions and how things move. And what you will notice is if you go back a certain like X amount of blocks, you stop really accessing them. Coins that have sat for a while tend to sit for a while. Coins that move all the time tend to continue to move all the time. People will continue to move them. So if you store for the most part just the active, most recent stuff, you'll get a cache hit on most transactions and blocks.
Well, that was always my my sort of sense of like how it would work, is that you have X number of blocks that you need to store, which is, you know, the most recent ones, because that's how you can answer the questions that are going to get asked from the blockchain. And then as you get, you know, some number of ways away from those X number of blocks back, that the stuff that's happened just happened, and it's unlikely that those things are going to get access moved or touched in any realistic near term. I imagine some of the coins that get touched a lot would be things like Tibet Swaps coin and the Bridges coin and any other things that constantly are getting spent because they're fast forward spends or whatever. So you probably have like these certain types of coins that just constantly are getting used over and over again.
And those are the kind of things where, to be honest, we would probably add them to like some sort of always load list. You get like the major swaps, the major wallets, exchange wallets, etc. Anything that you know will be spending all the time, and just watch it. The other thing which we could do
is that the kind of thing where you're building up some intelligence within the node that it figures those things out and detects for the types of coins that it needs, or is it the kind of thing where you're going to start saying, well, we know about these, so we're going to make sure that these never get evicted from cache?
basically we know about them and we don't want them to get evicted from cache. But one of the other ideas I had is using Splash from Dexy. You can listen for offers. And one of the things that Intelligent Node could do is watch the offer pool that is out there and look at the coin IDs that are in the offers or might be spent and attempt to cache based on what's out there.
Pretty savvy, pretty cool. What are people intending to spend, and then you know that you're going to actually actively bring that into the cache or keep it in the cache for some period of time.
Yep, exactly.
Anything else that you've seen in the world of Chia that's got you excited? Things that we might not have heard about, or we pretty well covered it from what you've heard about?
From what I can talk about, that's it today. There should be some exciting stuff coming soon, though.
Ooh, juicy. All right, I won't try to pry for some kind of a leak of what you're cooking or what you have purview to, but I'm curious. So maybe when these things get released, you can come back and tell us about what you've been working on beyond this.
For the savvy people out there who want to read code, the Druid Garden library is open source.
All right, we'll have to go take a look and see if we can sleuth it out. Lucas, do you have any last minute questions for James before we let him go? We're almost at the hour anyway.
No, but Grant, I'm gonna be begging you to go read that code and tell me what's up. James, thank you. I'm very glad to hear that you guys have been working on a node. It's good to hear about that, and congratulations on releasing the Garden OS.
Thank you so much.
We'll be watching for that 1.0.2 release, and if you haven't had a chance to go out and try it, probably all the really important bugs are shook out with the last release. But if you're waiting for that next one because you're loath to install any software which isn't 100% cooked, watch for 1.0.2, and that's probably going to be the golden release, likely, right?
Yeah,
James?
so 1.0.2 is going to be kind of the first. We're hoping to get out of beta after this release. It also is going to include the newest version of the Farmer. So that, like I said, was just given to me by Max probably about a week and a half ago. The website for it should be coming up today. The Windows build is finally done. So the website for the Farmer, the Linux builds, and the Windows build will be available today at some point. And then the OS, I would imagine, some point later this week. If you do want to get started today, the 1.0.0 release will update to the 1.0.2 release. And you can do that straight through the web interface. Super easy. So if you want to get started today, please feel free to get started. You don't have to wait for 1.0.2, but it should be out soon.
This week, though.
This week.
Right on. All right. Well, thanks for giving us that update. Thanks for coming on FOMO, and we'll see you next time.
Thank you.